everyone. Today we will talk about queues, one of the other linear kind of data structure. Are queues. So queues are another kind of linear data structure which allows you the insertion and deletion from its two different ends. That means insertion in a queue can happen from one end and the deletion can happen only from the other end. The end from where the insertion happens is known as the rear end of the queue, whereas the end from where the deletion happens is known as the front end of the queue. So it is also known as the first in first out kind of data structure. Like for an example, if you are standing in the queue of buying the tickets, so the very first person who enters into the queue gets the ticket first and gets out of the queue uh, in the same order. So that is known as a queue. So initially when if you want to initially the values of front and rear both happens to be 0. So if I want to insert the value in the queue, then I will increment the value of rear equal to 1, and for the deletion I'll increment the value of front equal to front plus 1. So for a given size, let's suppose uh, this is the box given to the right is the array implementation of your queue. So initially, as you can see in the first row, that f and r, which represents the front and the rear of the queue, happens to be 0 both. Now if I want to insert the new values, a b c have been inserted, so the rear will be now c, and the value of rear will be 3, whereas front is at 1. So now if I want to delete a, so a has been deleted and now front has moved from 1 to 2, whereas the rear stands there itself at 3. Now again if I want to add d, so rear will move by 4, and after adding e, the rear has moved to 5. Now in the last row what I am doing is I am deleting a which has already been deleted. Now I am deleting 2 and b and c as well. So now my front has moved from 2 to 4 where d is present. Now if I want to insert f, so what will happen? At 5 I cannot increment the value of rear more than 5, because that is the maximum size of my array. So what I can do is I will see whether front is not equal to 1 or not. So if rear is equal to 5, so what I have to do, I have now again want to insert a new value, and now my index position 1, 2 and 3 are taken. So I will initialize the value of rear to 1 and I'll insert value f over there. Then similarly g and h will be inserted, and rear will now become 3 and front will now become 5. Now once e has been deleted, now front will now become, e has been deleted and f has been deleted, so front will become now 2. So this is how the working of the queue proceeds. Can be performed on the question. So if I want to insert the value in a queue, if the front is equal to 1 and the rear is equal to n, which is the maximum size of the array, or if the front is equal to rear is equal to 1, then I will say overflow condition has occurred. Now if the front is equal to null, then I will set front equals to 1 and rear equals to 1. Otherwise I'll set rear equal to the maximum limit, and then I'll set rear equal to 1. Else I'll set rear equal to rear plus 1, and then set the queue the rear queue at the rear index equal to item, and then I'll return out of the algorithm. So for deletion, I'll check for the underflow condition. If the front is equal to null, then I'll print underflow and exit, and set item equals to queue ka front. Then if the front is equal to rear, then I'll set front equals to null and rear equals to null. Otherwise I will set front equal to n and set front equal to 1, or I can set front equals to front plus 1 and then return. This is the deletion when queue has been implemented as a linked list. So in insertion, I will simply check for the overflow condition, which will be given by if avail is equal to null, then I'll simply write overflow and I'll exit. If not, then I'll create a new node by saying that set new equals to avail and avail equals to link of avail. And to the new nodes info part, I'll set the value of item and link of new will now equal to null. Now, if the front is equal to null, then I'll set front equal to rear equal to new. Otherwise, I'll set rear link of the rear equal to new and rear equal to new, which will make new node as the rear node. And then I'll exit. Equal to null, then I'll write underflow and then I'll exit and set the item equals to info of front and set front equals to link of temp and temp equals to front, and then set link of temp equals to avail and avail equals to temp. By this statement, what I am doing is I am returning the deleted node temp to the avail list, and I'll simply exit. Queues. The very first type of queue is doubly ended queue, or it is also known as DQ or DIP. So input is restricted, output is also restricted in a particular queue. Now deletion from one end and insertion from both ends can happen in a DQ, and insertion from one end only and deletion from both ends. Okay, this is the way how your DQ happens. Like if there can be two types of DQs, one is input restricted and one is output restricted. In input restricted, insertion is from one end and deletion can happen in both ends, and in output restricted, deletion happens from one end but insertion can happen from both ends. Now another kind of queue is priority queue, which is very important. In priority queue, what is happening if the list queue is being implemented as a same linked list? So what happens in a queue, particular node? What happens? There is a simple node which is divided into two parts: data and the info part and the link part. So the info part has been divided into two subparts, which one has the actual information and one has the priority number, and the third part is the link part. So if the priorities are given to a particular node, this means the access of any particular node will happen according to its priority assigned. Like if there are three different nodes A, B and C, and they have the priorities numbers as 1, 2 and 3. So the node is having the highest priority, that means 1 will be accessed first, that means A, and then B will be accessed at it has the next priority level, and then C, which is having the next priority level. Now what happens if two nodes have the same priority? Let's suppose B and C both have the same priority number as 2. So if I come to access the data of priority number 2, what will happen? I'll have a clash for B and C. So to break that clash or tie, what I will do, I'll check which data element has entered the queue first. If B has entered the queue first, I'll access B first, though both of them are having the same priority. So entering the queue becomes the tie breaker.